As the video about the SPH is one of the most viewed ones of this channel, I decided to keep on going technical, and today I'm going to try to show you what is a Markov Chain Montecarlo, and at least in concept explain how it works. This is Monterey, and this is your Cosmic Kingdom. So for this exercise, I have created this system. This system has two parameters. One on the x-axis with 50 states, and another one on the y-axis with 50 states. This gives me a total number of 2,500 states. Okay? And for each state, we have a different value of the function. In this case, just for simplicity, we have one maximum here and another one here. Okay? So the thing is, how do I get the value of the maximum quickly? There is the obvious solution. Start by this cell and be like swiping this way, swiping down, swiping this way, swiping down, and store the maximum value and the numbers of the cell until we get to this point. This is for 2,500 states, so it's not that bad, but imagine that you have a very, very complex system out there and you want it to do it quick. So the Markov Chain Montecarlo, it's just it's called Monte Carlo because it's based on randomness. So the first thing it does is just select a random number that will just place ourselves in some point of the 2,500 cells, like there. Okay, that's our first guess. And then we draw another random number that will take us to another cell, like this one. And what we do now is compute is if the value of that cell is longer or larger than the value of the previous one. And if it is, we stay. In this case, because it's larger, we stay. We then get another random number and takes it down, and we don't want that one. So we just reject the jump and stay where we are. And we do this many different times. So we go up to here because we're going up, we stay there, we keep on going up, we stay there, we keep on going up, we stay there, we go down, we don't want that, we just go down again, we don't like that, we go up, oops, we just jump the valley and we go down, we don't like that, we keep on going up, 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 until we reach the top. This case is an example, and we know the shape of the function. In this case, is a 2D function, but normally you don't know it. So we have done only 11 jumps versus 2,500. But on a normal data set, you will have billions of possibilities, and this is a very quick way. And this is a very quick way of sampling your phase space and being able to determine the probability of the likelihood of a certain set of parameters. These are results that I ran a few years ago using MCMC. Here, for instance, you have the different parameters of the universe. In this case, for instance, here you have the density of dark matter of the universe versus the density of dark energy, and you have these values. This is the fraction. So dark energy should be around something of the 70%, and dark matter somewhere between 25-27%. But you see the point. So you can have an idea of how the different parameters of your simulation or of your data set work around together and get the best values for them. So I think that's all for today. And this is a little bit tricky episode, but I hope you enjoyed it, and see you guys next week. Bye bye.